During the coming decades, natural gas will remain the prime energy source for Western Europe. Due to the central position of the Netherlands within Europe and the excellent transport network available, the Netherlands is considered the gas roundabout of northwestern Europe. Gasunie owns and operates the Dutch distribution network. New contracts for delivery from Gazprom in Russia, among others, as well as contracts for supply to the United Kingdom, necessitate substantial investments to strengthen and expand the distribution network within the Netherlands. A new pipeline is one of the methods. A gas line connecting Borkum in Friesland to IJsselmeer in Holland, crossing the IJsselmeer, a lake previously known as the Zuiderzee. This crossing involves a concrete-coated gas main of approximately 30 kilometers with a diameter of 48 inches that will be installed under the lakebed and will pass under the dikes on each side of the IJsselmeer. Due to environmental conditions, including the shallow water depth of the lake, there is no room for standard equipment. New and innovative solutions must be found to install the pipeline crossing. A unique project that asks for a unique approach. A major challenge for Nacap van Oord, a joint venture that combines Nacap's expertise in pipeline installation and onshore operations, and Van Oord's experience in dredging, offshore, and marine construction. With their roots in the Netherlands, both companies have a proven track record in executing major international construction projects. In December 2005, the contract is signed and the project team is formed. The project team's challenges will be demanding, challenges that require custom-made solutions. Intensive brainstorm sessions, a tight planning schedule, and the ingenuity of a motivated team result in the work starting before summer begins. The most suitable method of construction of the dike crossings is horizontal directional drilling. To prevent water from the IJsselmeer draining into the lower-lying hinterland once the tunnel is drilled, a cofferdam is created on the water close to the shore. The 80-meter by 5-meter cofferdam is a watertight box constructed of sheet piles. The pipeline will be pulled from land into the water through the drilled tunnel. This requires that the drill rig be located on the water side, a well-engineered concept that has proven to be very successful. The drill rig is transported to the site in sections. Once on site, the drill rig is assembled, placed at the front of the cofferdam, and prepared for operation. Operations begin with the drilling of a pilot hole with a limited diameter. The pilot hole is kept open with the drill mud, a natural clay suspension. By extending the length of the drilled tunnel, a nature reserve adjacent to the works on the Friesland side of the project is also passed without disturbance. When the drill reaches the surface on the land side, the drill bit is replaced with a so-called fly cutter. Using this, the diameter of the hole is enlarged in several stages until it is wide enough to pull the pipeline through. The pipeline for this section is prepared to the required length and welded together on land. This pipeline is fitted with a pull head and connected to the drill string. A rotating jet head is attached to the drill string and used to clear the way. The pipe pulling operation can now begin. When the end of this pipeline surfaces in the cofferdam, The drilling is complete and the rig can be dismantled. The cofferdam is then prepared to receive the marine section of the pipeline once the onshore preparation works are completed. On the boundary of land and water, the heart of the project is the string yard. Here, one by one, the 12-meter-long pipe sections are cleaned, aligned, welded, checked, grinded, coated, and finally concreted at the joints. In this way, pipeline strings with a length of 500 to 700 meters are assembled and prepared to be towed to the coupling location on the water. To assure buoyancy, the strings are capped and fitted with floats. Several strings ready for the tow to the offshore location, where the coupling spread is waiting. Meanwhile, several kilometers from the string yard, construction of the onshore line continues toward the location of the substation, where the new pipeline is connected to the existing network. The land lines are first welded and then laid into a 3-meter deep trench to assure protection of the pipeline. Here also, a horizontal directional drilling operation is used to cross a canal. On the water, trenching operations of the lakebed have begun. The IJsselmeer trench is excavated to a depth of 2.1 to 3 meters. The backhoe dredger dredges the material from the lakebed. The dredged soil is then loaded onto split barges and used for backfill of the pipeline trench. Part of the material is used to immediately backfill part of the open trench where the pipe has already been installed, and part of the material is temporarily stored underwater to be reused at a later stage. In the meantime, contact has been established with the central control room of the IJsselmeer to warn traffic of an unusual transport underway. The complex operation of towing the strings to the coupling spread has commenced. One by one, the strings are collected at the string yard, carefully inspected and cautiously towed by multiple vessels to the coupling spread. The first string is towed to the cofferdam, where the tie-in to the land line is created. The offshore pipeline is brought into position and lowered by releasing the buoyancy tanks one by one. This method assures controlled sinking of the pipeline into the pre-dredged trench. The released buoyancy tanks are then retrieved to be reused on the next string being prepared in the string yard. At the opposite end of the first string, the coupling spread is ready to make the next joint. The coupling spread consists of two specially prepared jack-up barges, securely positioned on the lakebed, and two shear legs. The coupling platform is operated from one of the jack-up barges. This setup provides a stable and controlled working space for the coupling operations. The most complex part of the project can now begin. When the next string arrives, the end of the previously installed pipeline is hanging in the strops of the first jack-up. The new string is carefully maneuvered alongside the second jack-up and prepared for alignment. The ends of each pipeline, hanging in the strops, are lifted out of the water over a length of more than 100 meters. Two specially designed A-frames, aided by the shear legs, perform the lifting operation. As soon as sufficient workspace is achieved, the coupling platform is swiveled into position from one of the jack-ups. The first step is to remove the end caps of the two strings. These covers are cut off and the pipe ends are carefully cleaned and beveled. The two pipeline ends are accurately aligned. The stable position of the jack-up barge ensures that the two pipe sections do not move during the welding operations. The high-quality welding is performed in a special welding tent that is placed on the working platform. This tent provides a controlled environment for welding operations, which is necessary for the integrity of the pipeline. After lowering into the water, the buoyancy tanks are removed and this pipeline section is installed into the excavated trench. The same procedure is repeated until the entire pipeline is installed. During coupling operations, the backhoe dredger continues to excavate the trench ahead of the coupling spread. In order to protect the underwater pipeline, the trench must be backfilled. With utmost accuracy, making use of state-of-the-art RTK positioning equipment, the split barges are positioned above the installed pipeline. The backfill material is released by splitting the barge down its length, thereby opening the hold, and the dredged material drops from the barge and covers the pipeline. Upon completion of this process, the installation of the pipeline across the IJsselmeer is complete and testing can begin. This unique project entailed laying the landline, pre-drilling from a cofferdam on the water, pulling the pre-assembled pipeline string through the drill hole under the dike, while at the string yard, welding the concrete-coated pipe sections into strings of up to 700 meters. Towing the strings fitted with floats over the IJsselmeer to a unique installation spread, coupling the strings into one integral pipeline, lowering the pipeline into the underwater trench, and backfilling with previously excavated material. The technical expertise and ingenuity of the project team from Principal Khassouni and Nacap van Oord guaranteed that custom-made solutions were developed and applied, addressing the unique challenges of this project. This was accomplished within a limited time frame, adhering to high quality and safety standards, and with respect for the environment. Sailboats can again take ownership of the IJsselmeer, unaware of the unique asset under their keel. A vital part of Khassouni's transport network, providing uninterrupted transport of gas from Eastern Europe to the United Kingdom, combined with the Balkhsand-Bakken line and the other sections of the main network of Khassouni, completing the gas roundabout of Europe.